In this video, we're going to be looking at the concept of concavity. You may have heard the word concave before, concave and convex. Concavity has to do with the bending of a function or the curving of a function. So basically, a graph is concave upward on an interval if it bends upward over the interval, and concave downward if it bends downward. So I'll give you an example here. This is one of those concepts where a lot of times the first time you hear about it, it's like, well, then it's just the same as how the graph curves. And it's like, well, not necessarily, because you can have, or not how it curves, but like how it's related to increasing and decreasing. And it's like, oh, so if it's decreasing, it has, it's concave down. And if it's increasing, it's concave up. That is actually not true. So it gets a little confusing. I will try and make it easier to understand. So here, I'm just going to draw this kind of swoopy curve thing. So the graph is starting from a low point here on the left. It's curving up and off to the right to make kind of a hill. The hill curves down as we keep proceeding to the right to make a valley, and then curves up at the end. Okay, so that's what we've got here with this particular curve. Now, we can think about, here's our graph. Where is it increasing? Where is it decreasing? Well, if we want to think about increasing and decreasing, it's increasing here on this left-hand side where we're kind of starting and curving up to the hill. When we get to the top of the hill, it stops increasing, right? And starts curving downward, decreasing. The y values are falling as we go into that valley. Once we hit the low point of the valley and we start coming back out again, the function starts increasing again. Now, again, that's the idea of increasing and decreasing. That is not the same thing as concavity. So concavity, again, looking at the way that the graph bends. And one of the easiest ways I think of to think about it is if you're looking at any particular part of the graph and you think, like, if I were to pour water into this part of the graph, would it hold the water or would the water fall off? That's kind of a way to think about concavity. So here, when we're looking at this function, this part on the left here where we make the hill, this whole part, that's concave down, right? If I tried to pour water on this hill, it's just going to leak off. So that's concave down. It is a downward, if you think of kind of the graph as a cup, the cup is downward. Okay. Then this point right here in the middle of the graph, where the graph switches from being concave down to being concave up, the point where the concavity changes, that's called the point of inflection. So if, for example, you're doing a homework problem and it asks you to find the point of inflection, that is the point where the concavity changes from concave down to concave up. And then if I look at the right part of the graph, the part that's kind of what I referred to as the valley, and then it curves up and off to the right, that part is concave up. It has an upward facing cup shape to it. And again, if I think about pouring water in here, the water's going to stay. It's not going to leak out, right? So that is our concave up. So those are the differences between concave up and concave down. Let's look at a couple of other graphical examples that I think will help. If I'm thinking about, did I switch? Nope. Come on, switch to the black one. There we go. If I'm thinking about a parabola that opens upward, for example. So just, here's my basic parabola. This entire thing is concave up, right? There's no part of the graph where the kind of cup shape switches from being something that could hold water to being something that can't. It doesn't change its concavity. It's an upward cup shape the entire time. Okay. On the other hand, if I think about a graph that looks like this, where we kind of start down at the lower left-hand side, we curve, whoops, I want a different color for that. There we go. Start down at the lower left-hand side, curve up, and then off to the right-hand side. Kind of makes a very flattened out S shape a little bit. So if I'm looking at this graph, the left-hand side of the kind of flat S shape here, that is concave up. Again, upward cup shape, concave up. This upper right portion of the super flattened out S shape here, there we have a concave down. Right, the cup shape of the graph, the rounded part, is facing downward. And then here, in between, that's where we've got our point of inflection. And then I'm going to do one more graph, and then I want to point out one other important thing. So let's look at this graph. This is almost going to look a little bit like a absolute value type graph, except it's going to curve instead of having straight sides. So coming from the origin, the graph goes up and curves off to the right-hand side, and then going to the left, it's a mirror image. So it makes kind of a curved V shape, if you will, but it still has that sharp point at the origin. So if we look at this graph, you'll notice that it's actually concave downward the entire time, right? Both of these, their cup shape is pointing downward, both sides of that V, right? Cup shape is pointing downward. That whole thing is concave down. Okay. Now, this is again why you want to think about the differences between concavity and whether the function is increasing or decreasing. They are not the same concept. So our first function that we talked about, the quadratic function, notice that the left-hand side of our upward pointing parabola, that's decreasing. And the right-hand side, the side to the right of the vertex, that's increasing, but the entire function is concave up. Okay. Similarly, if we look at our flattened out S function, that entire function is increasing. Right? As we move from left to right across the graph, the Y values are always going up. So the function is an increasing function, but we still have a portion of it that's concave up and a portion of it that's concave down. And then our last function, the kind of curvy V function, whole thing is concave down. We have a decreasing left-hand portion of our V and an increasing right-hand portion of our V. Because again, notice as we read left to right along the graph, the Y values initially are falling and then they start rising. Okay, so decreasing left-hand portion, increasing right-hand portion, but the entire curvature of the line itself is concave down.